This final video is just going to go through the last part of this question, which talks about the percentage of each element present in the solid and the liquid phase at each temperature within the table listed below. The other thing to notice is in this part of the question, they've asked for an 80% cadmium alloy. So we've previously been doing 90%. So you need to read these kinds of questions carefully so that you don't get those kinds of details missing. But here we are talking about an 80% cadmium. So it's still a high percentage of cadmium, but not as high as the previous kind of questions where we're talking 90%. So what are we needing to do here? Well, the first thing we need to do is we do this exactly like we did with the previous diagrams, which were the completely soluble mixtures, where we look at the liquid phase and the solid phase, and we can see up over here, it's pure liquid. There is no solid at all. It's only once we go past this liquidous line that there's some solid phase. So when we get to this temperature, let's say at 350, which is the one that we're talking about here, so that's the 350 temperature, what we're going to look at is saying, well, there is 0% cadmium and bismuth in the solid phase at 350 because it is all liquid. And because this is an 80%, 20% mixture, it's 80% cadmium and 20% bismuth. And by the same token, when we get to the end of this at 100 degrees, so down here, we're in the completely solid phase. So we're down here where it's a complete solid. And even though we know that this is going to be a solid which has got some eutectic and some solid particles of cadmium, which we've talked about before, the total mixture has to still be 80-20 because that's what we initially put in. So in this case, it's going to be 0 liquid because over here, we've got a 0 liquid phase. We're in the solid phase. And it's going to be an 80-20% mixture of cadmium and bismuth because that's what we started with. We can't just kind of lose bismuth or cadmium throughout the process. So those ones are pretty easy because they're nice and simple. There's the ones in the middle that are a bit trickier. And so for these ones, we just got to use our liquidus line like we've always done. So for the 250 mark, we go over here and we say, well, this is the cadmium line, that's cadmium liquidus line, and we come down and we see that's about 66%. I've probably drawn that a little bit skew, so let's call it 67% cadmium. So at 250, the liquid phase is going to have about 67% cadmium. And when we look at this in terms of the solid phase, we notice that there is no connection to the solidus line because that's down below. We hit this barrier or the side of our diagram over here, and that's because if we remember what we talked about, what we're going to have is liquid and solid cadmium starts to form because this is that mixture that's too much cadmium. So the cadmium that starts forming is solid cadmium. It's 100% cadmium. And so the solid phase is going to be 100% cadmium and 0% bismuth because it's that pure cadmium particles are starting to form. And then we go down to the next line. So I'm just going to get rid of those ones. We're going to go down one dot lastly, obviously if this is 67%, then the rest must be bismuth, which is 33%. And then we go down to 200. So we move down to the 200 mark, and again we go along the line, we come down. That looks like at about 53%. So in the liquid phase, there's about 53% cadmium, which means there's about 47% bismuth. But again, the solid part of it is 100% cadmium and 0% bismuth. Because again, at this point, we're still at liquid. We've got larger particles of cadmium forming. All right? And that's your finished diagram.